let's keep trucking through our problems. So let's do the next problem. So this one says enough A is added to an empty container so that the initial concentration of A is 0.1 molar. What are A concentration, B's concentration, and C's concentration at equilibrium? And they gave me the equation and they gave me the Kc. All right, same like we always do. What am I looking for? What's my question mark? I want to know A, equilibrium, B, equilibrium, C, equilibrium. Okay? When you do this, the first thing that should pop in your head is, ooh, I'm trying to find these equilibriums. I'm probably going to have to do an ice table. Okay? Remember, if you're trying to find the equilibrium concentration, it's an ice table. That's it. I know. But once you know how to do it, not too bad, I promise. All right, what did they give me? They gave me the initial concentration of A, and they gave me the Kc. All right, so like I said, we got to do an ice table. So A is going to go to B plus C. Ice. All right, what do I know initially? I know A's initial concentration, 0.1. If A's initials, if I have A's initial concentration, what does that mean for B and C? What do we always do? If I start with reactants and I'm trying to go forward in my reaction, that means I don't have any B or C. So that means these are 0. Because I have reactants, I'm going to products. All right, so if I have a reactant, he's negative, products are going to be positive because I'm going from A to B and C. So I'm losing A and I'm making B and C. There's a 1 here, so he's a 1x. He's a 1 here, he's an x. 1x, he's a 1 here, here's a 1x. Equilibrium. You see how the setup is the exact same. So once you figure out how to do these, they become really repetitive. All right, now I want to find X because I want to find these concentrations. So what did they give me to help me find X? They gave me Kc. That's what you have to read into. You have to figure out what did they give me to help me find X. Did they give me an equilibrium or did they give me the Kc? If I'm trying to find the equilibriums, like in this case, they're not going to give me one of them. Okay, so they gave me the Kc. All right, so what is Kc? It's going to be my B times my C over my A. All right, let's plug it all in. 2.5 is equal to X times 0.1 minus X. We can rewrite that to be X squared divided by 0.1 minus X. All right, so now here's where it gets tricky. I've got X squared on the top, but the bottom does not have a squared. So I can't do my little square root thing to solve for X really fast and pretty. Okay? This is where you have to do it more tricky, and it's the longer way. I can tell you this, you're gonna have homework on this, you're gonna have a problem like this, so you need to know how to do it. Okay? All right, so let's look at how we're gonna solve for X. So first, let me kind of rearrange this. So let me move him over. So now I have 2.5 times 0.1 minus X is equal to X squared. Distribute my 2.5, so 2.5 goes to here, and then he goes to here. 2.5 times 0.1 is 0.25, minus, because this is a minus 2.5x is equal to X squared. Now, I want everything on the same side, and it's easier if my X squared is positive. So let's move all of this to that side, and we get X squared is equal to X squared plus 2.5x minus 0.25 is equal to 0. I'm going to write that on the next slide in case you can't see it. Let me see if you can see it. Kind of. Let me write it on the next slide. So we had 0.25 minus 2.5x is equal to x squared. We just want to move all of this over. So we got x squared plus 2.5x minus 0.25 is equal to 0. All right, so here we go. We need to solve for this. We have a squared, we have an x, we have nothing. This should look like the quadratic, like a quadratic equation. So how we're going to solve for this is we must use the quadratic equation. All right, so let's see if we remember what that is. So the way the quadratic works is if you have an ax squared plus bx plus c is equal to 0. My a, my b, and my c are just numbers. Okay? So these would be numbers like 1, 2, 3, or whatever. To solve for x, x is going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, remember, you're going to have this equation, okay? Because it's a take-home test in essence, because you get to do it on the computer, so you're going to have that equation. So you don't have to memorize it. So you should be pretty happy. You don't have to really memorize much. You can have a little equation cheat sheet for the next test, okay? Benefit of being online. All right, so let's look at this. So my equation, just rewriting my equation, right underneath this guy so we can see it. There's a 1 right here. So my A is 1, my B is 2.5, and my C is negative 0.25. Because it's supposed to be positive, so if it's not positive, you have to write it down. So now I can take these and plug it into here. So x is equal to a negative b, negative 2.5, plus or minus b squared, 2.5 squared, minus 4 times a times c, which is a negative 0.25. All of that divided by 2 times a. All right, let's start chunking through it and simplifying it. Okay, x is equal to negative 2.5 plus or minus 2.5 squared is 6.25. 4 times 1 is 4. 4 times 0.25 is 1. And this is a negative times a negative, so we get a positive. Guess I didn't need my square root to be that long. All over 2. All right, let's keep simplifying. X is negative 2.5 plus or minus the square root of 7.25 over 2. X is equal to negative 2.5 plus or minus the square root of 7.25 is 2.6926 divided by 2. All right, now we need to separate it because we're going to have a positive and we're going to have a negative. So we got to figure out both of these, okay? You need to figure out if it's a positive or if it's a negative. So if it's the positive, x is equal to negative 2.5 plus 2.6926 divided by 2. If it's the negative, x is equal to negative 2.5 negative 2.6926 divided by 2. All right, let's work this out. Here, you get a negative and a positive, so that's going to become a positive number. And then when we divide by 2, we get 0.0963. Here, we're going to get a negative and a negative. So it's just going to be a negative number divided by 2 is a negative 2.5963. Okay? Now, we got to go back and figure out what we need to do next. Okay? Our whole goal was to find these equilibriums. So let's rewrite that. Okay? So my A, concentration and equilibrium, was 0.1 minus x. My b at equilibrium was x, and so is my c. So x and my c at equilibrium was x. Okay, so same thing. If this is x, my x cannot be a negative concentration. So that means this is a no-go because I cannot have a negative concentration. So that means that this is the x I'm going to use. So now we just plug it in. So 0.1 minus 0.0963 gives me 0.0037. And then this is just going to be 0.0963 and 0.0963. So now I have my concentrations for A, B, and C. Just like last time, we can do our check. So let's do the check. So we said Kc was equal to 2.5, and my Kc was B times C over A. Let's plug it in. 0.0963 times 0.0963 divided by 0.0037. Okay, simplify the top. That gives me 0.009274, and the bottom is 0.0037. So that gives me a Kc of 2.5. That's 2.5. That's 2.5. So I'm good to go. All right. So that's when I'm trying to find the equilibrium concentrations. So, whoops. Whoa, went way too far. Here we go. Trying to find these equilibrium concentrations when I have Kc, but my Kc doesn't turn out to be a nice, simple square root issue. Okay? If you can do this one, this is the hardest problem of this chapter. So if you can get through that, you're good. Okay? You only have those 3 different types of ice tables for this chapter. The rest of things is pretty much no math. Okay, so this was the hard lecture. So if you made it through today's lecture, this one lecture, you're doing awesome. Great job. Go get like an ice cream cone or, you know, some sort of treat, whatever you like. And congratulate yourself, take a little break, and feel really happy about yourself. If you did not understand this, maybe watch it again in a little bit, see if you can soak it in, and then email me or write a message on the office hours document. All right, keep trucking.